Hi guys, and welcome to today's Sunday session. Okay, so in today's Sunday session, we're going to focus on Leaving Cert Geography, and we're going to look at the formation of rocks. Okay, so this is what we're going to focus on. It's going to be a quick revision, and we're going to look at the three different types of rock formations. Okay, so this YouTube live presentation is by myself, Keith Walsh. Okay. And like I said, we're going to focus on rock formation. Okay, so it's really important that we know the objectives of today's class. Okay, so what we're going to do is we're going to be at the end. We're going to be able to name and understand the three different types of rocks. We have to explain the formation of the three different types of rocks, and we're going to analyse the ways in which the questions come up in the Leaving Certificate exam. Okay, so one thing that you should look at is the geography Leaving Cert syllabus, and to see like what actually does the syllabus say that you need to know. Okay, so this is 1.1. It's for the rock cycle. Okay, and we've got our statement, and students should study the geotectonic setting of the formation of igneous, both plutonic and volcanic, metamorphic and sedimentary rocks. Okay, the process of weathering, both physical and chemical, and then we've got the human interaction with the rock cycle. Okay, so the one we're going to focus on today is this one. Okay, so it's the formation of three types of rocks, and they are igneous, metamorphic, and sedimentary. Okay, so this is what we're going to focus on today for the lesson. What do we know already? Okay, so what things do we know already? So we know there's three different types of rocks. So from junior cert, you would have known that there's igneous, there's sedimentary, and there's metamorphic. Okay, for igneous rocks, we've got basalt, we've got granite. Okay, they would have been two. Basalt is a black colour, granite is dark grey. Use of basalt, it's used in building materials, and an example would be the Giant's Causeway. Granite, it's dark grey. It's used in kitchen counters, and an example of where you can find granite is in the Wicklow Mountains. The next one is sedimentary. Okay, so two examples, we've got limestone and sandstone. Limestone is grey in colour, sandstone is kind of brown, kind of like reddish kind of colour. Limestone is used in road chippings, and an example of where you can find it is in the Burren in County Clare. Sandstone, brown red in colour, a use of it is building materials, and the Connemara Mountains is an example of where you can find sandstone. And lastly, we've got metamorphic rock group. Okay, examples of metamorphic rocks are marble and quartzite. The colour of marble, it comes in a range of colours, but black is one of the colours. It can be used in fireplaces, and it can be found in County Kilkenny. Quartzite for metamorphic is grey in colour. It can be used in kitchen countertops, and an example place where you can find it is the Wicklow Mountains. Okay, so now we know the three different types. We're able to name the three different types of rocks, and that's what we've learned from junior cert geography. Now we're going to look at a definition for each one. So igneous, they're formed when molten magma cools and solidifies above or below the crust. Okay, so we should know from junior cert geography that it's above or below the Earth's crust. Sedimentary rocks are formed when the compression and sedimentation of sediments remains at the bottom of the ocean. So basically they're compacted, they're compressed and cemented together at the bottom of the ocean. And then we've got metamorphic rocks, and these rocks have changed due to great heat and or pressure. Okay. So what are rocks? Well, rocks are solid materials made up of one or more minerals. And a few characteristics. So minerals, what are minerals? They're different minerals that make up like different rocks. Other characteristics of rocks are the hardness. So rock hardness depends on how strong the rocks are cemented together. Colour, the colour depends on the mineral content of the rocks. Structure, some rocks have layers, which we will call strata, while others are just a solid mass. And texture, rocks have different sizes, shape, and arrangement of mineral grains. Okay, so this kind of brings us on to so that's what we know from junior cert geography. So now we're going to, obviously for Leaving Cert, we know that we need to talk about the formation of igneous, sedimentary, and metamorphic rocks. So a good thing that I think you guys need to do is to look at the past exam papers, okay? And if you look at the past exam papers, you can then like work out like what questions actually come up on the paper. So I'm just going to bring you into ExamRevision, and I'm going to show you. We can look at the past paper questions. Okay, so if you change this, you can change this to Leave Insert Geography. We go into our exam builder, our exam questions, and Leave Insert Geography. I'm going to change it to rocks because that's what we're looking at. And we're going to look at the one how often the formation of rocks come up on Leaving Certificate exam paper. So 2019 was a formation of rocks. So we had explain the formation of each of the following with reference to examples you've studied. So one sedimentary rock, one metamorphic rock. If you click on this, it can give you. We will get the marking scheme. Okay, so then we can see how the question is broken up. Okay, so if you name a sedimentary rock, you get 2 marks. If you name a metamorphic rock, you get 2 marks. And then an explanation, you can get 6 to 7 SRPs for the formation of sedimentary rock and 6 to 7 SRPs for the formation of metamorphic rocks. Okay, so that was 2019. Okay, so scroll down. Okay, this is rock cycle. We scroll down. Okay, so 2016 we had explained the formation of one igneous and one metamorphic rock with reference to Irish examples. Okay, so again, the marking scheme is here. We can see. So that was 2016. 2015, we had explained the formation of sedimentary rocks with reference to examples, to Irish examples. And we have the rock cycle in 2015 as well. 2014, explained the formation of igneous rocks with reference to Irish examples. Okay, if we go down to 2013, explain the formation of metamorphic rocks with reference to examples from Ireland. And if we go to 2012, we can see describe the formation of one sedimentary rock that you've studied and briefly explain how this rock may be transformed into metamorphic rock. 2011, we had explained the formation of 2 igneous rocks with reference to examples that you have studied. Okay, so we can see that this question is very popular, and we can see that it comes up like very frequently on the exam paper. So it's a really important question, and it's one that is easy to learn off, and it's easy to score well on, provided that you have enough information. Okay, so we're going to start with looking at sedimentary rocks. Okay, so I'm going to talk you through here, and I will give you H1 standard answer for both sedimentary. For the 3 of them, for sedimentary, for igneous, and for metamorphic formation of rocks. So sedimentary rocks are formed when sediments at the bottom of the sea are compressed, compacted, and cemented together naturally. Okay, so they're compressed, compacted, and cemented together naturally. Oh, by the way, I will leave in the chat. I will put in. I'll put all these slides so you can get them afterwards. Okay, so you can just watch it. You can take some notes during this lesson, but then I will have the slides available for everyone to get after class. So I'll pop them in at the end of the lesson. These sediments are tiny rock fragments, and these include like sand, clay, plant, and animal remains. The sediments are compressed and compacted together, like compressed and compacted together because of the weight of the overlying sediments. And the process of compaction and cementation is known as lithification. Okay, so lithification is an important process, and I'll just show you exactly what it is. Okay, so lithification is when you've got the grains of sediment. Okay, they've got like in between the sediments, they've got water, and what happens is the water leaves the sediments, and then the pores shrink, and what happens is they get cemented together. So the grains get cemented together like naturally, and this process is known as lithification. Okay, so sedimentary rocks are usually laid in strata. Okay, so again, I'll show you what strata is. Strata is layers. Okay, so we can see here the rock has lots of different layers. Okay, and these layers are known as strata. So the sedimentary rocks are usually laid down in strata, and they usually have like bedding planes between the strata. Okay, these series of layers are known as stratification. The next one is there are 3 different groups of sedimentary rocks. We've got organic, we've got inorganic, and we've got chemical. We're going to look at each one now. So organically formed sedimentary rocks are compacted remains of plant and animals, okay? And an example would be limestone. And I'll quickly bring you to, this is an example of a limestone rock, okay? So it's an organic sedimentary rock. And it's found in every county in Ireland, apart from Wicklow. And it's organic because it's basically, it's the dead remains of dead plants and animals, okay? So dead plants and animals were basically cemented and compressed together, and because of this, it's known as an organic rock. It contains calcium carbonate. Okay, so calcium carbonate, this is the natural cement that holds the limestone rock together. It varies in colour from greyish to white to black to dark grey, and an example of where you can find it is the Burren in County Clare. Okay, so I'll just bring you back to where we were. Okay, back to where we were, here we go. Inorganically formed sedimentary rocks are compacted remains of pre-existing rock fragments, okay? An example of an inorganic rock is sandstone, and I'll bring it to sandstone. This is what sandstone looks like. It's an organic sedimentary rock, like we said. It's very coarse, so it's usually brown or red in colour. It's formed approximately 400 million years ago. Sediments are laid down in layers, okay, so it's got the strata. Each successive layer is then compresses the next layer, cemented to form sandstone, and an example is Comer Mountains in Waterford. Chemically formed sedimentary rocks are formed when waters evaporate from the sea area and the sediments are compacted together by the weight of mud and sand into stratified rocks, so stratified into layered rocks. Gypsum is an example, and that can be found in County Cavan. Limestone is a sedimentary rock that has joints and bedding planes. Okay, so joints and bedding planes. So I'll show you exactly what I mean by joints and bedding planes. So bedding planes are the horizontal lines going across. It's like the weakness in the limestone rock. And joints are the vertical cracks and lines that are in limestone rock. And each one of these layers is known as strata. Okay, like I showed you earlier on in the limestone rock. And it's in sandstone rock, we've got like these layers are known as strata, okay, and the horizontal like crack between each one of these layers, each one of these of the strata are known as bedding planes, and the vertical crack are known as joints. And usually what happens is water usually percolates its way down through the bedding planes and down through the joints, because these are lines of weakness within the limestone rock. So bedding planes are horizontal cracks which between the sedimentary rock, which we looked at. Water can easily move down through limestone, down through the joints, along the bedding planes, and then go down through the joints again. Limestone is slowly and chemically weathered by rainwater, and this process is known as carbonation. Okay, so an important process, carbonation. So what is carbonation? Well, as rainwater falls through the atmosphere and soaks through soil, it absorbs CO2, so carbon dioxide. And when the rainwater mixes with the CO2, the carbon dioxide, it then becomes a weak carbonic acid. Okay, so it becomes a weak carbonic acid. And what happens then is, because when the weak carbonic acid lands on the bare exposed limestone, a karst region, it then weathers away the calcium carbonate. Okay, and this weak acid slowly dissolves the limestone because it dissolves the calcium carbonate, and the calcium carbonate is what holds the limestone together. It's what cements it together naturally. This process is very evident in karst areas, and an example of a karst landscape would be the Burren in County Clare. So I'll show you a picture. This is what it looks like. It's the Burren in County Clare. Okay, so it's a karst region. This is limestone rock, and it's bare exposed rock, which is and exposed to the elements. Okay, so an Irish limestone was formed over 300 million years ago, and limestone is usually grey in colour, like we mentioned earlier on. The joints are widened and deepened to become grikes. Okay, I'll show you these now in a few minutes. The large slabs of rock separating the separated into many grikes are called clints. Okay, and this feature is known as a limestone pavement. Okay, so if we have a look at this is the Burren in County Clare. It's also limestone pavement, and these gaps here are grikes. Okay, so all these gaps here that you can see that your foot would fall into, these are the big gaps are known as grikes, and then this bit here, the flat surface separating the grikes are known as clints. And these small little holes here on top of it are known as cairns. Okay, and those cairns will eventually get weathered away to form grikes. Okay, so grikes, how I remember it is G for gap, for grikes, and then the clints is the one that doesn't have the big gap in it. Okay, when river flows into karst landscapes, they often disappear through enlarged joints, and these are known as swallow holes. Okay, so as the water is traveling on the landscape, it'll often, like the rivers will often disappear down through swallow holes. The rainwater percolates, so moves down through the limestone. Limestone is a permeable rock, so that means that water can pass down through it. So P can pass down through it. And they go down through the joints and the bedding planes, because these are like the weakness in the limestone rock. It also has dissolving the limestone rock through the process of carbonation, which we spoke about earlier on, and because of eroding power, because of hydraulic action, and the limestone gets weathered away. Bedding planes are maybe enlarged into passages over time, and these can go on to create caves or caverns. Limestone caves contain many dripstone features formed by water, containing dissolved limestone evaporating in the warm caves. Stalactites, okay, stalactites hang from the ceiling. Okay, so stalactites, there's C for ceiling. Also another way to remember might be stalactites. It's holding on tight to the ceiling. While stalagmites grow up towards the ceiling. Okay, so stalagmites, maybe you might remember, they've got a G for ground, or another way that some people often remember is stalagmites. They might reach up to the ceiling, to the stalactites. If the stalactites and stalagmites, if they come together and they join together, they're not then known as columns or pillars. And an example where you can see this would be in the Alleyway Caves in County Clare. In coastal areas, especially near cliffs, where sedimentary rocks are exposed to sea erosion, bedding planes are very quickly enlarged by abrasion. So that's like the sandpaper effect. And hydraulic action is the sheer force of the waves from the sea. Waves constantly pounding against the exposed bedding planes and joints then quickly can form caves. The reason why they form caves is the reason why they attack the bedding planes and the joints is because that's their lines of weaknesses in the limestone rock. Inside the caves, the joints may be eroded by compressed air, or sometimes the process is known as air compression, right to the top of the cave, and if it does that, it can form a blowhole. An example of sea caves and blowholes can be found in the cliffs of Moher, and I'll show you what the cliffs of Moher look like here. Okay, so cliffs of Moher are a stalactite here. Oh, sorry, we've got a stalactite that happens in a cave. So what we have here is got the cliffs of Moher. Okay, and in here, this limestone rock can be pounded by the waves through the process of hydraulic action and abrasion and compressed air, and what it'll do is it'll eventually form like a cave, and if it goes through it, then the cave will get bigger, and through air compression, it can form like a blowhole. Okay, also like the sea stack, okay, that's formed is because at one stage this would have been a sea arch, okay, but again through the process of hydraulic action, abrasion, attrition, and air compression, it's eroded away, and the arch would have eventually fallen in, left the sea stack, and this will eventually be weathered down to like a sea stump. Okay, so that's sedimentary rocks. Now we're going to look at igneous rocks. Okay. So igneous rocks are formed at both destructive and constructive plate boundaries. Okay, so they're formed at both constructive and destructive plate boundaries. The cooling of magma may happen above the ground. So if it's above, it's known as extrusive, or if it's below, it's known as intrusive. Okay, a good way to remember that. Okay, so you've got the E for exit. Okay, so it's exiting like the crust, and if it cools, if the magma comes up and it or cools like within the surface, within the crust, it's intrusive. So I for in, or it's got in it on in the word itself, intrusive. And I'm just going to show you a little diagram. Okay, so this is the magma. Okay, in the magma chamber, and we've got our igneous rocks. Okay, so intrusive rocks would be when the magma comes down into fissure, it seeps up through fissures and cracks, and what happens is it might cool deep within the crust. Okay, and if it does, it'll form intrusive rocks such as granite. But if it makes its way up and it comes out, it's known as extrusive because it's exiting like the crust, and it will form different rocks such as basalt. Magma is pushed through the crust from the stenosphere. Magma rises up because it is less dense than the crust of the rocks. It also rises up as it is squeezed due to the pressure of the overlying rocks. Magma's temperature is about 1200 degrees Celsius and therefore melts some of the crustal rocks as it rises upwards. Igneous rocks are mainly found at destructive plate boundaries and constructive plate boundaries, as the magma is able to escape up through the faults and fissures. Okay, fissures are just another name for cracks. Magma or lava cools once it's exposed to the cooler temperatures, and crystallization will take place. Okay, so the speed of the cooling will influence the size of the crystals within the rock. So that basically means is if it cools really quickly, the crystals will be small. Okay, the crystals will be small because they don't have time for crystallization to happen. And the longer that crystallization has to take place, then the crystals will be bigger. So an example would be basalt rock, and I'll show you what basalt rock looks like. Okay, so this is an example of basalt rock. Okay, dark kind of black color, and you can't really see crystals. The crystals are really small; they're very tiny within the basalt rock because it cooled really quickly on the Earth's surface. So it's an extrusive rock, and if they cool, if it cools really slow, okay, so that's what happens is they will be large crystals. An example would be granite. Okay, and granite is an intrusive rock. This is what granite looks like, and many of you might have granite in your houses. And a really popular place where people have it is in their kitchen countertops in their homes. Okay, because it's really nice, and obviously it's got big crystals, so it kind of sparkles. And if you have granite in your kitchen, you'll probably be aware of and understand what I mean by when I say it sparkles. And it's an expensive rock, and it's also a very hard rock, so it's able to take some wear and tear. Igneous rocks can be intrusive. Another name for intrusive is plutonic, okay, or they can be extrusive, so out of the ground, exiting the ground, depending on whether the magma cools or the lava cools, if it's above or below. If the magma cools beneath the Earth's crust, then they're known as intrusive rock, and if they cool above the Earth's surface, they're known as extrusive. Okay, so if it's below, it's intrusive. If it's above, it's extrusive rock. Granite is an intrusive rock, and basalt is an extrusive rock. Okay. Granite is an intrusive igneous rock formed when magma cools slowly under the Earth's surface, and as magma cools slowly, the large crystals form. Granite is composed of 3 minerals, okay, and these minerals are mica, feldspar, and quartz. The proportions of these minerals vary, and because they vary, it creates a range of different types of granite, and because of so they create the different types of granite with different colors and different textures. So some people might have a white kind of greyish colour for their granite in their kitchen. Someone else might have like a darker grey kind of blackish colour. So it can vary depending on the minerals that's within the granite. However, grey is like the dominant colour. It's the one that is mainly found within Ireland. Granite is a strong, resistant rock, and it's used in building materials and kitchen countertops, like we said. When granite is exposed to the rain, it breaks up to form clay. An example of where granite is found in Leinster. An example where granite is found is in the Leinster Batholith. Okay, so Leinster Batholith, which formed 400 million years ago during the Caledonian folding period. Magma chambers formed underneath the surface where the magma slowly cooled to form granite. Nearby rocks were baked and cooked by intense heat, and they were metamorphic sized, and so basically they were changed into metamorphic rocks. So an example would be sandstone was metamorphosized into quartz. Still on igneous rocks, as the overlying layers of softer sedimentary rocks were eroded, the harder igneous batholith of granite was exposed. The Sugarloaf in Wicklow is an example of where granite was exposed, and is also coated with a sprinkle of quartzite, and that's how it gets its name of the Sugarloaf. Basalt is an extrusive igneous rock formed when lava cools quickly on the surface. Lava escapes through fissures and volcanoes and is cooled quickly by the air and water. Thus, basalt is a smoother with tiny crystals and has a glacier texture, and is also known as obsidian. Okay, and I'll give you so this is what obsidian looks like. Okay, so it's much smoother, glossier finish. Basalt is usually black, dark kind of grey in colour. It's very hard rock, but it's not very attractive, so it's basically used in road construction. Okay. Still on igneous rocks, when basalt rock is weathered, it forms deep, fertile soil, and this can be found. This fertile soil can be found in the fertile river valleys of Ulster. The Antrim Derry Plateau is a lava plateau in northeast of Ireland, formed when basic runny lava escaped from a fissure and flowed for many miles. So a constructive plate boundary, and it cooled quickly to form an elevated plateau. The giant Causeway formed hexagonal columns of basalt and a world-renowned tourist attraction. And I'll show you what I mean by the hexagonal columns. So these hexagonal columns were formed. This is basalt rock. Okay, so it was caused because lava cooled quickly above the Earth's surface. At the Giant's Causeway, lava cooled quickly, like we said. A stream where the water was caused the basalt to shrink and contract into the famous hexagonal columns. Okay, so these are just the pictures from the igneous rocks. And now we're going to go on to the formation of metamorphic rocks. Okay, so metamorphic rocks were once igneous rocks or sedimentary rocks. Okay. And they were changed both physically and chemically. And the reason why they were changed is because of heat. So great heat, I should use the word great. So great heat and or pressure. Okay, and that's important. So it's changed because of great heat and or pressure. If the rocks were changed because of the great heat, this is known as thermal metamorphism. Okay, so thermal metamorphism. This happens when heat from volcanic eruptions changes the rocks that it comes in contact with. So it's because of great heat. If rocks were changed because of great heat and or pressure, this is known as regional metamorphism. And this happens at destructive plate boundaries. An example would be during the Caledonian folding period. Okay. The process of change from older rock into new and different rock is called metamorphism. When metamorphism takes place, new minerals may form. The rock textures change. Old minerals will change shape, size, and arrangement, and this is known as recrystallization. The color of rocks may change due to a chemical reaction that takes place to the existing minerals in the rock, An older rock that exists before metamorphism is known as protolith. Examples of metamorphism are limestone changing to marble. Okay, so that's one example. Another example is sandstone changing to quartzite. A third example is granite changes to gneiss. And a fourth example is shale changing to slate. Okay, so really important. You will always get marks in your leaving certificate for giving examples. Usually, if you get asked metamorphic rocks, if the standalone question, there'll be 2 SRPs, so you need 2 examples. But I would try to know 3 or 4, because you can often get a third SRP for having like a third example. So examples are really good. It shows the examiner that you understand, and you're able to apply like geography. So try to learn off examples. There's 3 types of metamorphism. Okay, so the first type is thermal metamorphism, the second is regional metamorphism, and the third is dynamic metamorphism. Thermal metamorphism occurs at temperatures between 250 to 850 degrees Celsius. Magma pushing through the Earth's crust heats up the rock. This heated contact zone around a magma intrusion is known as an air hole. Marble is formed due to thermal metamorphism. So marble changed from a limestone rock, okay, and it was changed because of thermal, so because of great heat. So limestone came into contact at destructive plate boundaries, and because of the great heat, the thermal, it caused thermal metamorphism to take place and changed to marble. When the plates collide, limestone is subducted, and on entering the mantle, it melts to form magma. The magma then rises, cooling the surrounding limestone and then changing it to marble. Marble comes in different colours. So an example would be like green marble of Connemara. You can get white marble of Rathlin Island in County Donegal. And marble is also quarried at Clare in Tuscany in Italy. Okay, so if I just show you an example of what marble looks like, okay. So this is marble. Okay, so metamorphic rock changed from limestone or chalk, heat and pressure, and can be found different colours and can be used in bathrooms. Okay, it's highly valuable rock. Okay, because it's got a really smooth texture and it's really it's used quite often in bathrooms, in fireplaces, headstones, and graveyards as well, because it's I suppose it's a really strong hard rock, but it's also it can get like a polished finish, but it can be damaged because of acid rain. Okay, and that's important to note. And the Taj Mahal in India was built of white marble. Okay, so this is the Taj Mahal in India. Okay, so really beautiful building, and that was built out of white marble. Okay. Dynamic metamorphism occurs at destructive plate boundaries, where pieces of crust slip past each other in opposite directions. Okay, so in opposite directions, and is metamorphosized, resulting from deformation. Okay. Slate is an example of a metamorphic rock, and it forms because dynamic metamorphism of shale. At destructive plate boundaries, shale is put under immense pressure, so there's a lot of pressure, and the pressure compresses the shale into different layers of strata, which form slate. Strata is layers, like we said earlier on. Slate is waterproof and it splits easily into thin sheets, and this is why it's used on roofing, because it's ideal. Now, although slate has declined in recent years because of the greater use of tiles, an example of where you can find slate is in Killaloe in County Clare. Gneiss is formed from another metamorphic rock, schist. The schist formed from fine grains of sedimentary rocks such as shale and can be formed from granite. It is formed due to great pressure, which is regional metamorphism, caused as a result of moving plates at destructive plate boundaries. It's a really tough, hard rock comprising of feldspar, quartz, and mica. And an example of where I can find it is in Balmullet in County Mayo. Okay, and that's just our pictures that we had then. Okay, Okay, so this brings us back to the. I'm just going to go back onto the website. Okay, so I go back to the website. So what we have now is on ExamRevision we have these questions, okay, that we have that come up in 2019, that came up in 2016. It was 2016 Igneous and Metamorphic Rock we can now do. 2015 we can now do. 2014 we can now do. 2014 again, Sedimentary. 2013 was Metamorphic Rocks. 2012 was Sedimentary and Metamorphic Rocks. Okay, and then 2011, no date. There was a question on formation. Okay, yeah, again, formation is 2 igneous rocks with reference to examples. Okay, so it's a really popular question, comes up almost every year. Okay, and that was a quick revision, obviously showing you exactly the 3 different types of formation. I just want to take you through ExamRevision just to, in case some of you might not have used it before and might be wondering what do we have. So for example, like on ExamRevision, this is when you log in. This is what you've got. You've got your subjects. You can add more subjects and so on. Okay, you've got all these different things. You've got video tutorials. You've got quizzes. You've got PowerPoints. You've got exam questions. It's called Exam Builder because I'm a teacher. You've got notes and resource packs. You can track the progress of the students in your class and so on. Okay, so for example, if I want to go to my PowerPoints, I've got the whole course done. Okay, so we've got the physical, the regional, geographical skills, the 2 electives and the options. Inside the physical geography core unit 1, we have everything in here. Okay, so if you wanted like the rocks, okay, what we were looking at today, inside here there are 11 videos similar to what we've went through today, but just talking probably in a little bit more detail and probably a little bit slower because I'm explaining it where today's lesson is more on revision. Looking at so you can see the rock cycle, the formation of igneous rocks, economic value of rocks, metamorphic rocks, formation of sedimentary rocks, economic value of rocks, igneous rocks, how to date rocks, human interaction with rock cycles, so geothermal energy, and then the formation of metamorphic rocks. So it looks at it in quite a lot of detail, but also you have quizzes. Okay, so you can take, for example, like the igneous rocks, you can take there's 12 questions, and I'll just go through it really quickly. Okay, I'll just do it really quickly so I get a lot wrong, but you can see at the end what happens then is it corrects the answers for you. Okay, so I got 33. Okay, so you can see here, this is the one that I chose, I picked, but this is the correct answer. I got this one correct, I got this one wrong, so I picked limestone. The answer was granite, and so on. And what I can do then is I can obviously start over and take the quiz again, or I can go back and I can just take I can just go back and do another quiz if I want, or I can also look at the PowerPoint presentation. Okay, so within here I open up this, I've got the PowerPoint presentation, so you can get the notes. Okay, so if you're a teacher, you can use the PowerPoint presentation. If you're a student, you can obviously make your own notes from the PowerPoints. But also we have resource pack, and this resource pack then is for your notes. Okay, so if you open up this very comprehensively has everything you need. So this one has folding, faulting, and rocks. So folding, faulting, rock types, human interaction with rock cycle, past paper questions, and H1 sample answers. And then in here we have everything nicely simplified for you. So we have the formation of igneous rocks, and you'll see that I have more than 15 SRPs. So you can make your answer if you get asked an igneous rock. You've got the one on sedimentary, the formation of sedimentary. We've got on metamorphic. Okay, really, really nice compiled notes. This one question here is human interaction with the rock cycle. So you need to know geothermal energy or like gas. So the one I learn is we do is the geothermal energy. But I also have, if you're a student from a different school, you have the natural gas. You just need to know one. But again, these are really detailed. So you won't find notes as detailed as these. Okay, these will get you H1 standard if you write these style of answers. You've also got here, you can click on the past paper questions. That'll bring you to the website where it breaks it down in ExamRevision.ie. And then what we have is we've actually done out like the sample answer. If this one was to explain the formation of sedimentary rock, you should give 2 examples because you get 2 SRPs, and then each SRP is broken down to show you exactly what an SRP is, because I know that can be a confusion. Like what exactly an SRP is. Well, this will show you. Okay, you can see example H1 standard answer, and that's for the metamorphic. Then we've got our igneous. Okay, so the sample answers, if you don't want to write them yourself, here they are. Okay, you can have these. Okay, and this is then how humans interact with the rock cycle. So, that's like this for every subject that we have on ExamRevision. So at the minute we have, if we just look at my subjects, okay, so we have, at the minute we have junior cycle geography, junior cycle maths, junior cycle business, we've got junior cycle science, and then for Leaving Cert we have geography, maths, business, Irish, economics, German, chemistry, and Leaving Cert English. Okay, so all the subjects are exactly like that. They're all compiled by expert teachers in their field, and the whole course is complete for you with notes, PowerPoints, video tutorials so you can teach yourself, like quizzes that you can do and they correct for you and show you the exact answer. But the really great thing, I suppose, for students is the notes. You can go in here and this one's on weathering, mass movement, karst landscape, examples of human interaction, and past paper questions. And again, we have everything all done, all nicely laid out, really concise but really detailed. Okay, so if I just go back to the PowerPoint. Okay, so yeah, just again, these are the subjects that we have. So we've got geography for junior and leaving certificate. We've got science for junior cycle. We've got English for leaving certificate. We've got business for junior cycle and leaving certificate. We've got maths for both junior cycle and leaving certificate. We've got economics for leaving cert. We've got German for leaving certificate. We've got chemistry for leaving certificate, and we've got Irish for leaving certificate. Okay. Thanks very much for everyone joining today. Okay, so in 45 minutes we went through the 3 different types of rocks, the formation of rock types. There's a special for today on our website in ExamRevision.ie. If you go on to ExamRevision.ie and you go to purchase a subject, if you type in Sunday session, okay, so Sunday session, you will get 40% off. Okay, and this is only valid, okay, for until tonight. Okay, so it ends at 11:59 p.m. tonight. Okay, so but if you use the discount code Sunday session, you'll be able to get access to whatever subject that you want. Okay, so Sunday session. So when you go into the website, just type in Sunday session, and it will take off. A huge 40%. Okay. Also, you can follow us on social media. Okay, where we give we regularly update our social media. We've got Twitter, we've got Facebook, and we've got Instagram. ExamRevision for you is our Twitter. Our Facebook is just ExamRevision, and our Instagram is ExamRevision for you. Please do follow us. We put up lots of tips. We put up lots of sample answers. We put up lots of key information so to help you with your exams in all our subjects. Okay, so it's not geography. It's for maths. It's for business. For economics. It's for chemistry. And what we're trying to do is, as teachers, we're trying to make everyone be able to achieve and get the most amount of points that they can in their Leaving Cert. And because our resources are so detailed, so comprehensive, it meets like all learning styles. I think everyone that has signed up has really benefited from them. And if you'd like to, then please go ahead today and use our discount session. So that's it for today. Okay, I'm going to leave it there, and thanks very much for joining. If you if you like the session, we will let us know in the chat, and we will definitely we'll do more. We've got business next week, okay? So we're going to do a Sunday session for business, so for leaving certificate business. So make sure to check that out. Okay, thanks for watching, guys.